All right, gang, so here's where we left off yesterday. Problem 1722, measure the angle, standard position given, exact values for cosine and sine. You want to use your unit circle for that. You should be able to locate each of these values on your unit circle. The only ones that will be a little tricky for you are 20 and 22 because they're negative. Just remember we can turn them into positive angles, okay? So if I want to turn this into a positive angle, I can either look at my unit circle and go backwards around the circle, or I can add 2 pi to it, just like we would add 360 if it was in degrees. Now, for this one in particular, I can't just add 2 pi because it's a fraction. I have to have common denominators. So I would actually want to add 6 pi over 3, right? Because that would be the equivalent of 2 pi, and now they have common denominators. So that ends up letting me know that I have 4 pi over 3. So I find 4 pi over 3 on my unit circle, and I would say there that the cosine of that angle is whatever the x value is at 4 pi over 3, okay? In this particular case, that's going to be negative 1/2, and then the sine value at 4 pi over 3, okay, would be the y value, which is negative root 3 over 2. All right, same thing here. Okay, I'd want to add 2 pi to this. All right, however, I can't add 2 pi because they're not common denominators, so I'm going to add 12 pi over 6 because that's the equivalent of 2 pi. 12 divided by 6 is 2. That's going to give me 11 pi over 6. All right, so that's the angle that I can locate on my unit circle. Again, I could have just started at 0 and went backwards a sixth of a pi and found the same spot. Again, process cosine 11 pi over 6. Okay, is going to be the x value at that place, which is root 3 over 2. All right, and then the sine value at 11 pi over 6, okay, is negative 1/2. Fourth quadrant, y's are negative. Okay, so the rest of these here, again, you should be able to locate them on your unit circle. 3 pi over 2, the cosine there of 3 pi over 2 is going to be 0. And the sine of 3 pi over 2 is going to be negative 1. Okay, over here, again, you're just checking your answers now. So cosine of 5 pi over 3 is the x value there at that one. That's going to be 1/2. And then sine of 5 pi over 3, again, we're using our unit circle here, is negative root 3 over 2. 7 pi over 6, the cosine there of 7 pi over 6 is going to be negative root 3 over 2. And then the sine of 7 pi over 6, third quadrant, everything's negative, negative 1/2. And of course, this whole time we're remembering that the cosine is always the x value on that coordinate, and each of these ratios are coming from our special right triangles from geometry. So negative root 2 over 2 for the cosine value there, and the sine value of 5 pi over 4 is root 2 over 2. They're all isosceles. Okay, the next section here, and I'm not going to do all of these for you. I want you to do some of these on your own, is to find the indicated arc length. Remembering here that the whole arc, or the whole circumference of the circle, is 2 pi, all right, multiplied by the radius, which is 5 inches. Okay, so as I set up a proportion here, I want to solve for the arc length, in this particular case, m for number 23. So I know that my circumference here is 10 pi, okay, based on the information given. All right, so the circumference would be the arc length of the entire circle. So I'm going to set up a proportion. So 2 pi radians is the whole circle. 10 pi is the circumference, and we're going to let that equal 5 pi over 7, which is the portion that I'm solving for, over m. Now, it doesn't matter which position these are all in as long as they match. So the way that I have this set up here is I have my circumference and my arc length on the bottom, all right, and then I have my angle measures 2 pi and 5 pi over 7 on top. So as long as they coordinate with each other, this should still work, okay? So I'm going to cross multiply this, all right, to solve. All right, so it looks like I'm going to get, what is this? 2 pi m, and that's going to equal 10 pi times 5 pi over 7. Okay, and I'm going to start to solve here. So one of my pi's cancels on each side. All right, and then I'm going to divide by 2, okay, to get m by itself. All right, so it looks to me like I'm going to have something like m equals 25 pi over 7. Okay. I'm not sure if we need to round our answer to the nearest tenth. So yeah, you'll want to type that in your calculator and get an answer to the nearest tenth. Okay. So each of these sort of plays out in a similar fashion. All right, you're just setting up that proportion. Okay. Again, the whole circle. All right, so let me just go through that one last time. This number up here represents the whole circle. Okay, in radians. All right, this represents the portion, okay, that we're looking for in radians. Okay, this represents the circumference. And then this represents the arc length we're looking for, or the segment of the whole. Okay, so that's what that looks like. All right, so down here, pendulum swings through an angle of 2.4 radians. The distance from the tip of the pendulum travels 56 inches. How long is the pendulum? Okay, so again, similar problem here, right? So if we kind of diagram this out, all right, it tells us that this distance here is 56 inches. So the arc length is 56 inches. And it tells us the angle is 2.4 radians. Okay, and we're looking for how long is the pendulum. So we're looking for the radius here, or the length of the pendulum. Okay, so again, similar idea here. You're going to set this up as a proportion. All right, the part to the whole and so forth. Okay, and we're going to go ahead and solve that for what the radius of the pendulum is. So